Hey, welcome back. Good to see you again. Hope you're all well. Thanks for joining the channel. So, today on the bench I have the Rotel monster receiver. This is the RX-1603. Now, it comes in two pieces. This is the power amplifier and power supply basically on the bottom, and this is all the brains of the unit up top. It's so big that I couldn't fit it on my bench, so I stacked them on top of each other. So that's why that is. This was brought to me by one of my clients. He actually found this at a garage sale and paid. Do I dare tell you how much he paid? No, I won't. I'll tell you at the end of the series here. So he brought it to me. He says this originally came from Vancouver, Canada, and I believe it was in the repair shop once before because it had a dead channel. And so he bought it and brought it to me. He says it still has a dead channel. Well, I think the right channel is dead. I'm not sure. We're going to have to check it out. But he wants a full restore on it, and I don't blame him. It's a very nice piece of kit. And he dropped it off. When did he drop it? July 19th of this year, and it's already September 26th. So it's been sitting here 2 months. July, September, October, August, September. Yeah, it's been sitting here about 2 months, and I've been meaning to get to it, but you know, life things. So this is a two-piece unit. This is a two-piece monster receiver. They connect together in the back. I'll show you later. This is the face that connects with the back of the head unit. We'll call it the head unit, and we'll call this the power unit. Let's say that. And it also comes with the RK100 separation kit. And it gives you 6 feet of separation between the two units, so you can place your power amplifier down on the floor, out of the way, out of sight, and then just have your head unit up on display on your shelf and have them separated by 6 feet of looks like cable. Yeah. So, like I said, full restoration on this one. He wants me to go all out on it. I was looking at it. It's a very nice construction. This is 1975 era. So let's have a look at the controls. Here we have a power switch, 2 outputs for headphones, our bass and treble controls, and they have detents every so often here, plus and minus 10 dB. And they have 2 turnover switches, one for the bass, which gives you control over where the bass control actually boosts or cuts, and you got a choice of 200 Hertz or 400 Hertz. And you have a treble control with your choice of hinge at 2.5 kilohertz or 5 kilohertz, and then the same thing for the treble control. It's got big chunky knobs. It has low pass filter, and you got your choice of 15 Hertz or 30 Hertz depending on your needs. And you have a high filter, 8 kilohertz, and I suppose that produces some attenuation from 8 kilohertz and up. That's what I'm guessing. 3 outputs for speakers. Each has their own switch, and I believe these are analog, so you can only activate 2 at a time. So we'll get to that. On the right hand side we have our mode switch, stereo, reverse stereo, left, right, and left plus right mono. We have our function buttons up here, auxiliary Phono 1 and 2, AM and FM. Tape monitors, so we have 2 tape monitors, tape 1, tape 2, and then we have the ability to copy from 1 to 2 or 2 to 1. So we got our full control over our tape monitors. Balance control with center detent, loudness switch, and a muting minus 15 dB muting switch. Got a very nice feeling volume control here. It's got a very smooth action, and it's got the click feel. And I suspect that is probably an attenuator in there. I'm not sure, but we're going to check that out. And then you have a microphone input and a mixing potentiometer, so you can mix in your voice over top your music. Up top here we got our controls for the FM tuner. We got muting. It says interstage muting, I'm assuming. High blend filter, which reduces noise and distortion on weak signals. Multipath. And we have a de-emphasis of 25 microseconds. Each one has a indicator, depending on which button's pressed. It has an indicator. Over here it has an overload light. So I guess if you push this thing too hard, it will go into protect and the overload light will come on. Big fat chunky tuning knob. Looks like about 3 inches in diameter, but it's only about 2.5. And that's about it for this. It's beautiful brushed aluminum wherever you look. Yeah, it's a very nice look, very clean. It's going to clean up well and it's going to look good when we're done. So on the back of the unit, this is back of the head unit. It's a little unique design here because they had to switch things up. Now, you got to realize all of this real estate on the back of this is going to be mated with the power amplifier, so you can't really place anything on here. They have an interconnect for power. There's a socket and a plug. There is a connector here, multi-pin connector, that's poking out from the back, and it looks quite fragile. And that looks like signals, and these would fit on there. That's what that looks like to me. I have to read up on that to see how this is connected. There's 3 connectors here, and 3 connectors here, it looks like, so that's all good. So they moved all of the interconnects up top. So here you have your FM tuner input, AM tuner input. They have a connector here that's kind of European looking. It looks like a what they use on the European televisions for connecting up a VHF signal. FM detector out, in case you don't like the detector in here already. We have our main amp in, preamp out, and there's a switch here to separate or unite. Tape monitor 2, tape monitor 1 with a DIN connector. We have our auxiliary input, Phono 2 and Phono 1 with a DIN connector. That's unusual. And we have a phono sensitivity switch. It goes from high sensitivity to low, and then there's a ground lug. And we have a busted AM bar antenna. Now it looks like somebody tried gluing this. There is glue on here. But both pieces are broken. We're going to have to find a solution for that. Also on the top here, got some heavy corrosion, and the paint's damaged, and it looks like, I don't know, it looks on the auxiliary connector I can see green corrosion, so we're gonna have to clean this connector off. It looks like somebody maybe spilled battery acid or some kind of corrosive substance on the lid. The client asked that I remove the lids from both units and send them to him, and he's going to take them in and get them repainted. He apparently has matched up the paint from Rotel, and he got a recipe for the paint, the black paint from Rotel, and he's going to have these repainted for him at a body shop, I believe. So when I get these removed, I'll give him a call and he can come get them, and then we'll continue on. But there is also some corrosion down here. It looks like it's spilt onto here and down here. So I'm wondering if some got inside. That would be disastrous. So typically what happens here is you normally don't have this RK100 separation kit. If this would be in place, you would have the connectors for here, probably down here somewhere, and then here you would have the connectors for this. But this separation plate kind of hides all that and keeps it hidden. So on each side of this power module we have a huge heatsink, which takes up the whole width of the side. And there's 4 devices in here, so they're running 2 transistors in parallel. And they have 1 amplifier on this side, 1 on the other side. And then in the center here is your transformer and your filter capacitors. And any support circuitry is in here as well. On the back of the power up module, we have 3 speaker outputs, 2 switched power courtesy outlets, and our power input and nameplate tags, serial number, and then it has 4 feet, which protects these from being smashed. This is a very heavy unit. It weighs quite a bit on its own. I think it's close to 40 pounds or more, and placing it down on any of these screw connectors would just crush them. So they put 4 feet on the back, and then they have 4 feet on the bottom, which is kind of nice. So continuing on, just take a look at the power amplifier internals. There's a steel lid. I'll send this off and get repainted. So we have a big toroidal transformer. It's huge, built specifically for this stereo. It's got the RX-1603 number on it. There's a board along the back here. This is relay switching for the 3 outputs. Right in the center here we have looks like a power supply board. It has a bridge rectifier in the center, all our fusing. It looks like it has soft start, and I see a relay down there and some heavy duty resistors, so I'm assuming that might be a soft start circuit. 2 big filter cans about the size of a tomato soup. These are, what are these? I can't even see them. 22,000. Is it 100 volts? 80 volts. 22,080 volts. This power wires. Take this off. The cover for the individual. You can see the transistor connections down here, and same for the other side. They have another cover here. So they do have some thermal tracking here with this diode that's mounted thermally. And this is that power amplifier board. It's got all the original caps, Elnas. They look pretty tired. Everything's filthy, pretty dirty and filthy. The other 3 fuses down here are intact, so everything's good that way. We just have 1 dead channel. Don't see anything that's been blown up. Yeah, so it's going to be enjoyable working on this thing, I think. There's going to be a lot to do. A lot of cleaning. Everything's covered with, it's kind of like a greasy film. Well, more dust, gray, like a gritty dust, not a linty dust, you know what I mean? So I'm going to have to clean a lot of stuff here. Okay, let's have a look at the head unit. So we got 3 different connectors here for the separation kit, and they all have different number of pins. You can see that, and then they all have the space on the one side to get the polarity correct. So you can't really pin these in backwards, and you can't really mess them up because there's different numbers of pins. So it's pretty straightforward. This is our signal and protection circuit, overload, light, all that kind of stuff flowing back and forth between the head unit and the power block. Okay, yeah, here's a close look at this corrosion that's on here. It definitely took the paint off, whatever it was. A little bit of pitting here and there. Yeah, anybody competent in model body should be able to fix that up pretty good. So let's flip this over, and I can see a bunch more corrosion up here where it seeped in to where the between the 2 metals. A little bit of a heat stain up here in this corner, which kind of translates to down here. I see a couple power transistors, so there must be a power supply down here in the corner. So let's put this aside. Here's the head unit, dial string, and it's got a 6-gang capacitor down here. It looks kind of really clogged with dust. You can see a lot of dust in the... You can't, but I can because I'm looking straight down at it. Tuner front end, it's all in a shielded box. This box here is probably our phono stage. That's what I'm guessing. And then all along the bottom here is, what is this? This is all switching for things with to do with the radio. We've got our FM switches over here on this side, and this is our, and here's our function switches for the inputs. Looks like you got a couple read relays. There's one here for sure for muting. The circuitry looks dirty. Cleanable. We can clean everything here. It's all stuffed with original caps. Along the front we have 1, 2, 3, 4, 5, 6, 7, 8 lamps to light up that huge dial scale. Down below here we have tone controls, our tone circuits, and possibly our preamp. Got loose wires here. Under the shielded box we have our FM AM tuners, I'm assuming. Don't really know. And then over here looks like we have couple power transistors. It's a very modular look to it, and I think it's going to be easy to work on. It's very open. Let's take this cover off. No, that's all connected. Even though there's no ventilation here, we still have a lot of dirt buildup. I don't know how it's getting in. Did we have ventilation on top? I don't think we did. Yeah, we did have a little bit of ventilation. A little bit of ventilation on this side and this side. That's where the dirt's getting in. Let's have a look underneath. So all the screws are loose on the bottom panel. Removing it. You can see the corrosion theme continues. Here's corrosion down here. A few drops here. Something got through the middle. Otherwise it's just dirty. Okay, here's the underside. There's a lot going on here. This is a little amplifier for the microphone input. And here's our volume control. It's not an attenuator like I thought, but it's just a 4-gang pot. Some switching, balance control, switching. There's our mode switch. Tape monitor switching. There's a high-low filters, hinges. Bass and treble controls is all tone board down here. Underside of the tuner multiplexer. This here is the underside of that phono section I was looking at. And then this is the underside of the tuner front end, where all the input and oscillator is, and then they have the IF going over to the IF board, this little connector. Over here we got a power supply that looks pretty baked. Got a couple of 2SC 1444s as, where's that loose? 2SC 1444s as our regulators, pass regulators. Then we got capacitors. This capacitor here looks corroded. That's odd looking. So yeah, this is going to need a full recap for sure. 1975 vintage. We're getting on to, what, 40 years old now? No, almost 50. So, yeah, that'll all be taken care of. All these caps will go. Alright, so where do I start? I think I'm just going to start in this head unit, and I'm just going to start with taking on this power supply board. Oh, it's not popped in, that's why it's out. fell out from there's 4 posts here and one of them popped out. What I like to do is I like to connect the two together and do a test to see which channel is out and to see if there's any other problems. I think I might just do that. We can connect this up easy enough. I'll just bolt the two halves together and then we'll connect it up and we'll see how it works. So remove the screws for the separation kit and it just comes off, and then we have our 3 connectors. We just disconnect these 3. And then we have our 2 power connectors. We can pull these out. We have a male and female here. And these are females. And then there's our separation kit. I'll put this aside. We'll bring this back into the equation after we get everything restored and working 100%. Alright, so I got both halves bolted together, and this thing is freaking huge. It doesn't fit on my bench, so I'm going to have to work on it in 2 pieces. But yeah, it is monstrous. I don't have my tape measure here, but I bet you this is 24 inches long. But and just as deep. So I connected the 2 units together, the power and the signal wires. Everything's connected. I'm feeding in a 440 Hertz tone into the auxiliary. See if that works. This we should hook up an antenna, a wire for antenna. We'll do that as well since we're here. And let's see. Let's see how the FM works. Okay, let's turn some lights down. Ready to go live. Here we go. Fire in the hole. So, the soft start relay clicked. I don't know if you saw that. Oops, got a phone call. Let's try that one more time. I noticed that the dial lights did not come on immediately. And now they did. Okay, we're live. We're doing 60 watts. Getting anything out of our auxiliary. It's absolutely silent. FM. $66 watts. Okay, we might have a problem here. Oh, there was a bit of noise. That's, what is that? AM. 70 watts now, 71. So really having trouble getting the signal through. Yeah, there's not getting through. We got a problem with audio getting through. I got it on one channel. I'm going to explore this deeper here. So let me give it a test. Okay, playing around here. I'm not sure what's going on. This thing slowly climbs up in power consumption. That kind of that's worrisome to me. It's up at 75 watts now. But I'm feeding a signal directly into the power amplifier. and I got 100 millivolts going in. Oh, there we go. This switch is really baked. Yeah, the switch is I'm only getting one channel. Ooh, there we go. Both channels. Yeah, we got both channels working. This switch is really messed up though. I don't think that's the only problem here though. I have a feeling I think there's other things going on in here, but seems to be working. Okay, let me feed a signal back into the auxiliary. Okay, let's set this up for auxiliary. There we go. Balance, left, right. Left, right, muting, loudness, tape monitor, reverse, really dirty switches. Can hear a little bit of noise, random noise on the phono stage. Could be a failing transistor or a bad cap. Try FM. Stereo signal.
Way there is around it, so hot take 780-421-1039.
It's not picking up. It's not picking up great reception. There we go, good strong station. Yeah.
We're all trying to seek to win men and women and boys and girls to faith in Jesus Christ.
We're up at 77 watts now. So I think everything's working. It's just really crusty and needs a good clean, and it's going to need, well, full recap for sure. And it's going to need all these switches. It's going to need full attention because they are really dirty and messed up. Not so much the pots, but the switches are pretty dirty. But I think this is very doable. So let's get started. Okay, I'm done with the recap on this board. This board's called the Power Supply Protection Board. I think it has protection circuitry on here. I think there's an SCR, little SCR device. crowbar's protection. I'm not sure how that works. I didn't really look at it. The service manual for this is pretty poor. The one I found on Hi-Fi Engine, it's pretty grainy. Can't really read any details. It shows the layout of the board, but it doesn't show, you can't read the values. Now this board takes the positive and negative rail voltages from the other amplifier block, brings them in, and regulates it down to about plus minus 35 volts. Now you got plus minus 70, 72 volts coming in, and it regulates it down to about 35 volts, so we're losing about almost 40 volts here in these regulator transistors, and they get quite hot. And I don't know, you can see, but the heatsink compound has just turned to a cake of chalk. So I'm going to clean all these off, re-goop them, put it all back together. All the caps are done, which is a good thing. I checked caps as I pull them out, and they all held up pretty good actually, for considering the heat that's on this board. They all held up, except there was a couple that were leaking, and they had some kind of tan crust around them. They still held up on their values, and not too bad on the ESR. The ESR fell on a few of these, but actually they held up pretty good, those old Elnas, 50-year-old Elnas. But they needed to go anyways, they're gone. Now I have 2 or 3 transistors that are on my naughty list. This is the 2SA 750s, and they're known to go noisy. So we're going to replace those with KSA 992s, and that should fix that problem. I know I did hear noise when I was listening to the Phono stage, and I don't know where that noise was coming from. Either it was coming from a power source or it was internally generated in that amplifier, but we're going to get to the bottom of that one too. So just about done with this. I want to check some resistor values, clean the board, give it a good inspection, look at this, what is that? Some kind of stain. I'll clean all this up. Here's a look at the microphone amplifier that's on the front panel, and I just want to show you, this is pretty typical of all the caps I'm finding here. These Elna caps, they're leaking and they're staining the board with this tan colored, I don't know what it is, but it's dry, and seems like it's all these 8mm ones that are leaking. Let me pull these ones out and have a look at them. We'll see what they measure at, because they're measuring fine on ESR and all that, and then but they're just dumping this crap on the board that's failing. Okay, you can see the bottom. You can see the bottom. Oh, I dropped it. Okay, here it is. You see, it's the other one. I notice they have a crust around the top too. It's almost like it's wicking up through the plastic sleeve. So these test out here. Let's take a look at these ones. So this one comes back at 113 microfarad, 770 milliohms, which is probably pretty fair. That's a good ESR. The microfarads are high. Here's this one. (117 microfarad, 660 milliohms). So yeah, but these caps are done. So we're going to replace all these, and these are not Elnas. These are a different brand. So I'll clean this board up, recap it. I got the switch already desoldered. It's going to get cleaned, and then move on to the next part of this project. Alrighty, here's a look at the Phono amplifier equalizer stage. Back of the board. Yeah, I pointed this out. I don't know if I pointed this out yet. These are all hand soldered. This is not machine soldered, wave soldered like most of them are. It's all hand. Anyways, we have the same story. We've got capacitors leaking. Here's this brown stuff that coming out the bottom on that one, and this one here. You can see it, and this one here. It doesn't seem to be corrosive though. That's the thing. It's some kind of a. If it's electrolyte, it would be really corrosive, and it's like there's some on this resistor lead, but it's not really corroded. But I'm going to clean that all off. We got a bunch of transistors to change. I don't know if you can see this. Here, let me zoom in a little bit. We have the 2SA 750s. These two have to go. And we have 2SC 1400s. These two have to go. And then down here, I have the same thing. 2A 750s. One here and one here. And these 2SC 1222s, I'm not sure about them. I don't think they're on my list, but I'm going to maybe pull them out and check gain on them just to make sure they're good. Because I don't want any... This is kind of a difficult thing to get out. It was all held in with the wire wraps on the bottom. So you have to disassemble all the wire wraps before you can remove the assembly. It goes together like this. It's in a box, and once you get the thing out of the receiver, you can actually take the screws out, reach the screws to get to the box mounting. But we'll get this fixed up. I don't see anything else going on here. These tantalum caps, I generally leave those alone. They don't pose a problem unless they short, and typically they don't short unless they experience high voltage spikes or excess of their rating. So I'll leave those alone. But I'll get these other electrolytics and those transistors. Okay, finished with the phono stage. Got it all cleaned up on the back side. Looks pretty good. Now I changed 6 electrolytics, replaced 6 transistors. These 4 and these 2. These other ones here, 2SC 1222s. I don't think they're on my list. I think they're okay. I also made one other change. Here and here they had a pair of 4.7 microfarad tantalum capacitors in series to create a bipolar cap. So I just removed it and replaced it with one 2.2 microfarad film cap, and that will be more reliability, less parts count. So just to get rid of these. I don't normally change these unless they pose a problem, and the only time they pose a problem is if they short internally. If they're subject to over voltage or reverse voltage, they tend to short. But they're a electrolytic capacitor, but they're a dry electrolyte. They don't have the wet electrolyte like these ones do. So they're a lot more stable, and they last indefinitely because they're dry inside. But they are subject to, like I said, over voltage spikes, reverse voltage. So I just take them out and put them in film caps, and these are more reliable, and they'll last indefinitely. These two. So this can go back in. It's all cleaned up and ready to go. So I think next I'm going to tackle the tuner. I don't know if you can see this on the camera, but this is this flaky brown stuff that's been leaking out. It's all over here. It's on this one. All these Elna caps need to go. So I'm going to do this next. Basically just replace electrolytics. I don't think there's anything else to do. We'll come back to this tuner. This is the IF strip actually. It's your IF section, and multiplex. But we'll come back to this when we do our FM touch-ups and alignments and AM and all that. So just going to replace these caps. There's probably about 10 or 15 on here. Just get busy on that and do that next. Alright, so I was able to take the main tone board out. It wasn't easy. I had to remove all the screws and nuts from all the potentiometer switches. And that freed it from the front panel. I had to snip a couple of wire ties back here and disconnect a couple of wires. This one here at E4 broke. That's a ground. But I marked it, tagged it, so we have know where that goes. And then there was a wire here on the microphone amplifier board that was in the way, B1. remove that one, and it gave just enough room to work this back and pull it out from the chassis. So now it's hanging here. I'm going to remove all these switches and remove all the pots, and we're going to recap everything. I don't see any transistors that need to go, but give it a good look once I get it depopulated, and then we'll continue on that way. This one, quite a large board, so there's a lot going on here. A lot going on. You got your tone controls, balance, mode switch, volume control, all that stuff. All that good stuff is going to get taken off and cleaned. Alright, so I finished this board. Pretty much everything's done. Removed, I'll show you. I removed all these switches and cleaned them and disassembled them, cleaned them. These are the ones that were kind of problematic when I did the first test. But they should be like brand new switches now. I also cleaned the potentiometers and this switch as well. Potentiometers weren't a problem, but they'll be good. They'll be good for a long while now. So this board can go back in, but I'm just holding off because I have a few other things on the go here. Yeah, it's been cleaned, and I should actually go over one more time and check solder joints. I'm not seeing any bad solder joints on this Rotel, and yeah, cleaned up nice. So that's done. One thing you got to be careful of is all these wires are solid core wires, and the more you flip this board back and forth, you're going to tend to break wires on wire wrap posts. So I just got to be aware of that. This one here though was a bear. It comes out, you have to remove 1, 2, 3, 6 or 8 screws here, and that's what holds this part in. And then you have to remove also the LED board that is screwed in from this side. Remove the LED board and it comes out because that's all attached. And you have to really fight with it to get it back far enough, and then you have to pull the dial string around the switch fronts and get it. This is how you get it out. And this here looks like a multiplex circuit for the FM. It's got a HA1196 and some adjustments. So yeah, that's what I think that is. So this switch needs to be cleaned. Probably these trim pots, they're all covered and caked in dust. Everything here is caked in dust. So got to clean all this, recap as well. Got the same dead caps on here. And I've already started pulling the switches off to clean them. These are the speaker switches, but we're cleaning this one. These are the function switches, and then these are the FM mode switches. So we'll get all that cleaned and recapped. And once this gets back together, we're pretty much done. What else is doing here? Got a little bit of repainting to do here. A little bit of corrosion. I'm going to repaint, touch that up with some black paint so it's not so noticeable. Cleaned everything else, and we'll get that put back together. Got to clean these, and then I think we're done, except for, you know, testing and alignment. But we can't do testing and alignment until we get the power amplifier completed. So this has no power supply in it other than what the board is up here. Right, this is your power supply, but this power supply is fed from the other power block, because the transformers, there's no transformer in here for AC. So even though this is all complete, we still can't power it up until the other component is done. So we'll go through this, we'll complete it, get everything put back together, cleaned up. I've got the knobs in the ultrasonic right now, they're cleaning, and we're gonna get this looking good. And yeah, I'll get these. The main thing is these switches. I want to get those done next. That's my job for today. And this board, we'll clean this board, and then we'll start assembly again, because I think we're pretty much done cleaning and assembly next, and then we have to figure out what to do with this. And I have a few ideas. I have something in the works right now. So this is broken. Somebody tried gluing it, but glue is not going to hold this, whatever. It's just too heavy, and these joints will be just too flimsy. Alright, let's go through the cleaning of these switches. These are a little different than what I'm used to seeing. I've never seen these before, actually. they have a plastic cap with the latching mechanism is right here, this little silver dot. That's the end of the latching mechanism, and then there's a silver cap, and this cap hooks in at the back. So I already cleaned one of them. Let's do the other one here. Let's do the middle one. So actually you don't even need to remove these from the board, you can just do them from the outside. So you pull back the mainspring, and that releases my tweezers, and that releases the cap up front, right? So then you can let this spring go, and then if you push it in a little bit, you can release it from the back. See, there's a when I push it, there's an opening, and then that allows the back to unhook. So you can unhook the back. If it'll cooperate, just pull it back here. There it goes. So there's your cap with your latching mechanism. Let's put that aside, and then the plunger comes out, and you have your contacts on the sides, both contacts, and they're both pretty clean. We'll give them a wipe down. Actually, this gets a little bit of contact cleaner. Just going to use some of this CFC contact cleaner, no residue. Get a little bit on a cotton swab. Wipe down the contacts. Get the filth that comes off there. And then just give this a good shove inside and clean the contacts, the other side of the contacts inside there. It's not too bad actually. Give it a look, make sure there's no lint in behind there. And then we'll give it treatment with some D100. Just put a little bit on here. Are these coming loose? Looks like they're glued in place. So they might be loose, they might not. So let's put a little bit of a drop on that. Now on the bottom there's a rib that goes into the groove, like so. Make sure you don't crush the contacts, and then you should move freely. And then we just need to reinstall the what's left of this. So push it in far enough so that we can hook this part at the back. I'm going tweezers again. There we go. There. Back is in. Now we just pull the spring, the main spring back to allow this drop in place. There's a little nub there. Lift it up. Might be easier if I use a tool, some kind of tool. Let's try this. Lift it up, pull the spring back, and drop it in. There we go. And it's latching, so it's working. And it's clean. So that was pretty painless. I think I could do all the rest of these switches without removing them from the board. And I already desoldered them, so I can just put them back in, and yeah, it's pretty easy. These ones weren't a problem though. These switches weren't a problem. These are pretty good switches. They have a wiping action that keeps the contacts clean. From looking at the outside, the oxidation isn't too bad. But there you go. Alright, let's have a look inside the FM tuner front end, AM tuner front end. So this will be, just going to check to see what's going on inside, if everything's okay. I noticed the capacitor is quite dirty, so I'm going to take it and blow the air, blow it out with some compressed air. If I can get this to cooperate. There we go. Okay. Pull this off. We'll clean it up later. We put it back on. There we go. We've got 3 spots here. I turn my iron up. You're gonna need a lot of heat for this. Okay, hang on. Let me add a little solder. Sometimes it helps to add a little solder to get the heat to conduct. There we go. Be careful of the string here too. It's not going. I can't get enough heat on that. Got my iron set to max. I'm beginning to think my iron is not set to the right temperature. It's a little on the weak side. Just going to let it warm up some more. Try this again. Yeah, it's just too cold. Let's do the center one first. There. What I'm going to do is use a little heat here. Ouch. There we go. A little bit here. Okay. I need to do a little bit here. Let's move these wires out of the way. Well, it takes a lot of heat. It doesn't want to budge. Let's keep working on this side and I'll work that way. There we go. It's loose. Let it cool. Okay. Now we have this one here. Wow, it needs a lot of heat. It is melted, but it's not lifting. What the hell? Just want to inspect what's going on in here. So what I did is I removed the wire from AM1, and this is connected to the lid, and then I desoldered 3 points with a little butane torch, sorry. And it's loose now, so I can pull this back. It's cooled off. I can pull this lid back. Wondering if I can get the lid off without any further complications. I got a screw holding here. Yeah. There's a screw right here I'm going to have to remove because it's blocking. So let me be right back. Okay, typically you don't ever have to come in here and do anything unless you have like a dead transistor. But I took the cover off because I want to get in there with some compressed air. I want to blow out these plates on this variable air capacitor. There's quite a bit of junk in here. So I'm going to clean that up with compressed air, and then we're going to clean and lubricate all of the points on the shaft where it contacts the chassis, or the body, and makes a connection, because that has to be clean too, otherwise you get static when you tune. You get intermittence, but we're going to fix that up. So I'll be right back after I clean this up. So I'm just going to give it a shot of neutral 401B on the contact points. Now there's, what is there, one here. There's a leaf. There's a big brass rod that runs down the center of this tuning gang, and on seems like each support there's like a spring leaf that makes contact. You can see one here, and there's one there. 3, 4, 5 of them. So I'm just going to give it a shot of neutral at those joints where they spin, make contact with each other. Just give it a little bit, one in each shot in each one. I don't want to get crazy because I don't want to spray the plates. And then we'll just work it. Back and forth a few times. Okay, let's close them and take a Q-tip and see what we can. So get in here and clean out any of the excess. Neutral 401B has a lubricant in it. It's pretty dirty. Now I'm going to treat it with deoxit D100. Whoops. So D100 at each of the 5 points. Just going to put like a little, not even a full drop, just a little touch. And then it wicks into the places where it needs to be. And it will provide lubrication for that contact. So give this more rotation back and forth. Okay, what I'm going to do is close this up and put the lid back on. Put the lid back on, and I am going to solder it back in place. Okay, what I did is just heat it up until it softened the solder underneath, and then it just settled down. I pushed it down with a screwdriver, and now it's connected. So I got to do this one as well. Might as well use the same technique because we need a lot of heat here, and my little iron doesn't want to give that much heat. Let's do this one. Push down on it. Now you can't see anything, I know that, I'm sorry, but I think I got that one too. Let me see if I can lift it. Oh, that's good. And this last one, just going to connect this one up. This one has not so much thermal mass, so it's easy to solder that one. Okay, back together. Now let's connect up the wire again. Otherwise we won't have any AM reception. So let me get this wrapped around. There. Good. Everything's back together. Next on my to-do list is lighting. Now this is the light bar, and from what I can tell, I don't think I have any burned out lamps here. Let me connect it to a power supply. I've got 8 volts connected. Let's see what 8 volts does. Okay, so yeah, we're drawing 18 watts, believe it or not. That's a lot of current. 2.2 amps at 8 volts. But that's what we need to light up the business, right? We have to light it up from behind. So what I'm going to do is disassemble everything here, clean it, get the fog out, clean all the bulbs, clean all the reflectors, and then we'll put it back together. I'm not going to change any of these bulbs. They're all working. They all look to be good. I don't see any that are dark or black from the inside from overuse. They all look pretty good. So I'm just going to go run with this, clean it up, and put it in. Alright, so it's time to deal with this broken off AM antenna. So what I'm going to do is I'm going to cut out, this is riveted, I'm going to cut it out, and I have a cut-off disc with my Dremel. I'm just going to cut the rivet.
2 hours later.
Alright, so I spent a little time with the Dremel and I cut out the 2 rivets, and they came out in pieces because they fought me all the way. See, I ground off the top rivet part, but this bulge here, you can see that bulge, that was stuck in the plastic, so I had to fight with it to get it out. These are brass, and I just used a little cut-off wheel on a Dremel just to cut them out. So I have the 2 broken arms off, and these measure approximately 80 millimeters. So this is what I did. It took a little time to create this. I took some plate steel. Let's see what thickness this is. This is so it's about 111 thousandths of an inch thick. There's 2 pieces here, and they're bolted together. So I drilled holes at 80 millimeters on center, and then well, actually first what I did is I cut these 2 dog bones out of plate steel with my plasma cutter, and they were pretty rough. So then I dressed them up on the bench grinder and got them looking half decent. Drilled a couple of holes at 80 millimeters on center, bolted them together, then I continued with the grinding to keep them both the same dimension. It's pretty close to what I want, but it's not finished yet. I still have a lot to do to this. I'm not really going to thin this out anymore. I think that's thin enough, and I wanted to get these ends rounded better. They're not quite shaped properly, so I'm going to do that. Another thing, they have quite sharp edges, so I'm going to put 45-degree bevel on all the edges, and I'm going to sand them down and make it nice, and then paint them. And this is going to be my replacement for the plastic pieces that broke, right? So once I get this finished and we assemble this thing will never break again. Well, these plastic ears here are the most fragile part, and they can break if it's stressed, but this piece here will be not indestructible. Okay, so here's my finished product. It doesn't look the greatest, but it will work. Painted. Actually, what I did is I sanded it down with 120, sanded it down with 320, and then did the corners with 320 to put a nice smooth edge on them, and painted them with primer, painted them with flat black. So they're done. So I'm going to assemble it with these screws. These are the only ones I can find that will work. These are about 1.5 inches long, and these are M3 thread. So we're going to use that to assemble everything here. So let's put it together. I'm going to use a steel washer. One of these. And then this can go on here. I'll put a spacer in here. Plastic spacer to keep it from crushing on itself. That goes on there. Another steel washer. And oh, actually I gotta put the other one on. I forget the other one. The other steel washer. And I'm going to use self-locking nylon self-locking nuts, so that once these are tightened down, they'll never loosen off. And then we'll tighten this assembly up, and that's what it's going to look like. And then I'll do the same for the other side, and then we'll put it together. Okay, now it's assembled. All it's a matter of just tightening it down. See, right now it's loose, right? Just snug these up until it provides enough friction that it doesn't drop when it's under its own weight. So give this a little bit. It's getting better. Let's tighten this one up some more. There we go. This one a little bit more. It's not a very good design at all. It's very fragile. Okay. I think that's good. That holds the antenna up. It kind of droops over time, but I think the owner can adjust these too if it's not to his liking. Just snug these up just until that's good. Okay, I'll cut those off with a Dremel. Cut about 1/2 inch off, and those are self-locking nuts, so they won't ever come loose on their own. But that's the way it should be. All right. I'm pretty much finished. All I have to do now is put the knobs and buttons on, and that's about it. Some of these are quite dirty. These are actually put in the ultrasonic, and they're still coming in back dirty. So it's just a matter of some glass cleaner, blue glass cleaner, and just give it a good wipe, and they comes right off. Now, these buttons were glued on to the toggles, and I don't know if that's necessary, because if you give them a good push, they stick on there pretty good. But if you have one that's loose, you might run into troubles with getting to stay on. And one thing you don't want to use is epoxy or super glue, because you'll never get the button off again. Another thing you could use is hot glue, but hot glue doesn't work unless you heat the pieces up first before you insert it, because when you put hot glue on this and then you hit it with the cold aluminum, it will actually freeze the hot glue, and it doesn't do anything. It just kind of gets pushed out of the way. One thing I use, and I've been using this for a lot of years, is weather strip adhesive, and you can get this at your auto parts store. 3M makes a brand of this too, super weather strip adhesive. It's made by, this is Permatex, but you can also get it from 3M. And this is a solvent glue, so it's a sticky, tacky glue, and it comes out as a thick liquid. And then as the solvent evaporates, it turns into like kind of like a semi-hard rubber, and that's a really good for these kind of levers, because you can actually pull it off after if you have to, and it's not permanent, but it does stick on there pretty good. Silicone doesn't really work. Silicone doesn't stick. It's a really weak adhesive. It's more like a filler or a blocker. Like I said, hot glue will work, but you really have to be careful how you apply it. And yeah, but these are sticking on pretty good. This one's clean. Give it a good shove, bottom it out, and then a tug to check it after. This one's dirty. I'll clean this one up. Aluminum is really hard to clean. That's better. No, it's not. It's still dirty. It's got that grime from your fingers, you know, it kind of sticks to everything. There we go. That's better. Okay, looking good. Alright, now for the tuning knob, we have a little dilemma here. We have our set screws that are buried in the chassis, and there's no access here. There's access here, but it is actually probably about 2 inches in or so, 2.5 inches in. So what I find works is you get a T8 Torx screwdriver, and that's what the Torx, and it fits right into the hex. It's not the correct one. You could actually get the hex you can actually get the hex that is the right size, but I don't have that at the moment. But a T8 Torx will fit, and you can turn the lock screw. So let's put this on. Now you don't want to go crazy on the torque, because if you go crazy on the torque, you'll never get it off again, and you might end up stripping that little set screw. So I just got to get in here and see where that is, and just snug it down, and do the other one as well. I'm not sure what size. Actually, let's take it off and measure it. Let's take this off and measure it. Since we have it off, we can see what size it is. So, is it this one? This one here. That's the size. And this is going to be metric. So let's go to metric. And let's measure this Allen key. And it looks like it's a 2mm. 1.93 is a little small. It's a little sloppy in the set screw too. So 2mm set screw, 2mm hex. If you can get a 2mm hex driver, you could use that, but I use a T8 Torx, and that seems to work as well. And like I said, don't go crazy with the torque. You just want to snug it down. The knob's not going to fall off. Don't worry. Okay, there we go. Didn't clean that very good. Some schmeg in there still. One thing I was looking at with this design of this receiver is this power supply. It has this power supply that takes in the plus minus 72 or 75 volt mains, or the rails, and then it drops them down through a couple resistors, and we have a couple series pass transistors that drops it down to plus minus 35 volts for powering the rest of the unit, or rest of the head unit anyway. Now there's a lot of heat generated here, so yeah, 105C caps is pretty much a must. You got a lot of resistors putting out heat in this big heat sink. But then I also thought, you know, right above it, there's all this empty real estate right here. You could mount a aluminum finned heat sink on here. Just drill a couple holes, put it on, and then just put your series pass transistors up on that and run wires, and then it would make it a lot cooler down below. But I didn't do it on this one. I will see how it runs. I might yet, if it powers up and it's running really hot down below there, I just might do that. I might find a heat sink and mount those two TO66 transistors up on it and get that heat down from below and up above. Because it seems like kind of a waste to have all this space here and they're not using it for anything. They probably could have just mounted the power supply up here too and allowed it to radiate up, but they didn't for whatever reason. Alright, there it is, all back together. That's as far as I'm taking this one today. Actually, I gotta clean these knobs better. Get them under the light, they look terrible. But that's all I'm doing. Can't do any testing because we don't have any power for this. Our power comes from the power block, and the power block is currently in pieces right now, so I'm not going to plug that in. So no real big story here other than the capacitors were leaking and left a brown crust on everything. But overall, these element caps held up. They're still actually working and they're still doing what they're supposed to do. But look at the crust on this. Every one of them had, well, not every one of them, about half of them had crap coming out the bottom and it leaked all over. Easy to clean up. It wasn't corrosive, so I don't know. The element caps, see, here's another one. The element caps use some kind of electrolyte that's not corrosive to the circuit board, at least to copper. And yeah, it's all good. But no big story here other than bad caps, and they all got changed out. So that's it for this one. We fixed the antenna and cleaned it up, put it all back together. We're going to test it when we get a chance on the next, not probably the next episode, but maybe the third, if there is a third on this one. So that's it for this one. Thanks for watching, and stay tuned for part 2 because we are going to dive into the power amplifier. The beast of this thing is 180 watts per channel. I think Rotel boasted 250 watts into a 4 ohm load. I think that's what they were targeting, big numbers for big sales and big money. So that's it for this one. We're going to shut it down here and take care, and we'll see you on the next one. Thanks for watching.